Welcome back to Spinning the Past. Today I'm just doing a quick video on what's called a burn test. So the way we do the burn test, we use some sort of fire source. We can use some yarn or fiber, and I'm going to start burning it, and we're going to see how it burns, how it reacts. Different fibers will react differently to fire. So this first one is acrylic. So I just want to show you how acrylic behaves. And please do not try this at home. This is under safe conditions. Okay, so it burned up pretty quick. It started doing this curlicue, and this right here is really crunchy. You see? So acrylic is a plastic, and if it catches fire and it's on your skin, it will basically melt to your skin. The next one, this is going to be really fun. This is cotton. This is cotton. This is cotton roving. I'm not going to use all of it because I don't want to give up all of it. Don't need all of it. So yeah, sacrificing my forks just to show you. So this is cotton roving, and this should go up really quick. Again, if you're wearing cotton and you're near fire, this is how it can react. It went up really quick, didn't it? Okay, so that was roving. I'm gonna try this. This right here is cotton yarn. I want to see if there's a difference. This is cotton yarn. This is cotton yarn. Okay. So we also know not just how it burns, but what it leaves behind, which isn't much. It just really completely disintegrated. So that was cotton. Now another plant fiber, this is linen, and this should go up pretty quick. This is also a plant fiber. So it is getting a good burn there. Watch how this is behaving down here. It's making an ash. I'm going to burn that out, blow that out. So as with that, we didn't really have anything left. It pretty much went on flame, went up in flames. This is a little bit of silk. I couldn't find any 100% silk. This is a blend of silk and wool. And let's see what happens to silk. Silk is from the silkworm. Let's see what happens. So remember, this has silk and wool in it. Okay. Again, we'll look at the ash. There's a little bit of ash down there, but it went up, and it just kind of disintegrated. As opposed to the plastic, the polyester, the acrylic, it's like really tough right there. But this one just, so if you're looking for something biodegradable, those are the ones that are biodegradable. Now I'm going to talk about wool. Here's some wool. I'm going to do a couple of things with wool, because wool is supposed to go out on its own, but I've kind of had mixed results, so I have my theories. I'm gonna, this is Shetland. Well, let's see what happens to it. No. So it does burn. It does smell like burnt hair. And it went to charcoal. What's interesting is that it should self-extinguish. I'm gonna try it. This is a wool yarn. Let's see how this wool behaves. It's not even catching fire. There we go. Hope you can see that. Okay. It completely disintegrated, and it did not. It should self-extinguish, and I have a theory, but I'll tell you at the end. Okay, this is Lopi wool, and I have my theories of what's going on. Let's just see what happens. Does it self-extinguish? No. We do have a nice charcoal, and it does biodegrade. This is Lopi. Now I have here, this is some, I think this is Cormo or Merino, and it's been washed, but it has some lanolin. And I'm going to see what happens when we have wool that has a little lanolin in it. It does self-extinguish. The other wools did not self-extinguish so quickly. Come on. That is the way I expect wool to behave. It should self-extinguish. It should not catch fire quite readily. This one it keeps going. But the lanolin is dripping down. The lanolin is the oil in the wool. So, of the wools that I did, this Lopi wool has a moth-resistant protectant on it. This wool yarn also has a moth-resistant, and this is dyed. So I'm thinking that maybe something in the dye, something in the moth-proofing, that chemical may be combustible, but I don't know for sure, because these went up, and when I tried this earlier this week, the wool really did self-extinguish. It should have not caught fire. And the only one that kind of behaved like wool was this raw wool that I had. But back in the day, they would have known that if they were working around open flames, that the outer layers, at least, if they were wool, they didn't just go up in smoke, literally in smoke, in seconds. They would, the wool would have behaved similar like this, a little harder to catch fire. You could put out the fire quite easily. So that's why they used wool, and dressing kids in wool has the same thing. It was the original fire retardant of the day. Now, yes, we have chemicals and everything that can make children's pajamas more resistant, but remember, we added that resistance onto cotton, which, remember, this is cotton. This went up pretty quick. It just, like a candle, like a Roman candle. So when we are dressing in cottons, this, and you're wearing them, there is absolutely no protection for the natural, unless, we have to douse them with water. And the same way, the silk went up, but this isn't a true test of silk. Maybe I'll do a separate silk one because I have to work with silk pretty soon. And then the acrylic, this just turned hard and nasty. The acrylic, like I said, it feels like it's a hard plastic, like the anglet that's on your shoelaces. It's just, but that might fuse to your skin. The wools, though they did burn in this. They also, back in the day, when you remember when they said if somebody is on fire, you roll them in a blanket. Well, that was premised on the blankets being wool, and wool will smother and will suffocate. So wool is a good choice if you're doing historical reenactment and you're working near flames. I love wool. I wear it next to my skin. I wear it as outer layers, like most of the year, because I'm cold most of the year from socks and everything. But understand that when you start blending, like this silk, when you start blending fibers, then you know, if you were going to blend the wool with silk, that silk is going to catch on fire. Wool with cotton, that cotton is going to fan the flames, basically. And not all wools are alike. So this Lopi wool, for example, went up pretty fast. But again, I read on the label for the Lopi that they add some sort of chemical that is a moth proofing. But so that's just curious. That's something that I need to investigate. Do the chemicals for moth proofing, or whatever they do with the superwash, maybe, perhaps I don't have any superwash wool here. Do they change the the fire resistance of the wool that we're dealing with? Or maybe my experiment isn't, you know, that people are not, you know, exposed to these direct flames for a long time. Maybe I should have started the flame and just let it see what happened and not continually to have the flame on. So this is maybe part one of this series on the burn test. But if you want to know whether something is a cotton or a wool or a plastic fiber, I'm sorry, I can't help but it's acrylic. If you want, you can do a burn test. You can do it in a sink like this. Be sure you have water. Be sure you have something metal around it. Do not want you to burn down your house. Again, just kind of know what you're doing and have some sort of implement so that you're not actually holding it, but have something metallic. I didn't have any metal tongs, but you could hold it in metal tongs. But heaven's sake, don't do it on a windy day. Be sure you have some way to extinguish the fire when you do it. But you can take, if you're not sure, like you get those UFO skeins, then you can do a burn test, and this is one way. And it's not just how it burns, but the ash residue. So if you did this at home and you learn what the different residues were, not just how it burns, but the residues and the smells, and I can't convey the smells. Here now it smells like I had like a barbecue in my house now. But then you'll be able to at least make a pretty good guess whether it is, what fiber it is. So that's it today for Spinning the Past, and I hope you've learned something from this, and I'll catch you next time on Spinning the Past.